6 o'clock now. So, hi, good evening to all of you, and welcome to this session of Education Webinar Series, jointly organized by ACM India Council and ACM ITICSE chapter. These education webinars are being organized once in every 2 months. I'm Chitra Babu, Chair of ACM ITICSE chapter, the Indian counterpart of the Special Interest Group on Computer Science Education, as well as Professor of Computer Science and Engineering at Sri Sivasubramanian Nadar College of Engineering, Chennai. And I will brief you about ACM and its activities now. You can see ACM India at a glance on this slide, but let me give some examples of what being an ACM member means to you. You will be part of world's largest computing society. Out of 1 lakh members worldwide, about 10% of them are from India and half of them are students. ACM India is spread across the country mainly due to its chapters. We have totally 20 professional chapters and 200 student chapters across the country. As a chapter, you get access to ACM's Distinguished Speakers Program and ACM India's Eminent Speaker Program. You can invite any expert from these programs and ACM takes care of the travel. We also have the Best Overall Student Chapter Award, Best Chapter Website Award, Best Emerging Chapter, Best Chapter in terms of activities that have social impact, Best Chapter that has recruited maximum members, and all these awards carry a cash prize. ACM India regularly organizes summer and winter schools for students in different research areas in computer science. Faculty for these schools are drawn from prominent academic institutes and industry. The last summer school just concluded this last week's Friday, and the special interest groups in India, they organize national level conferences and symposiums like COTS, COMAT, ISEC, and Compute. Compute this year will be organized by Manipal University, Jaipur during November 9th to 11th, and the accepted papers will be indexed in ACM Digital Library. We have student scholarship program to attend these conferences. Please visit the respective websites for more details. We have something special for promoting gender diversity too, ACMW, which works for empowering women in computing. It has many initiatives specifically focused for female students. We organize Lady Ada programming competition and hackathon specifically for female students. We also have one of the summer schools exclusively meant for female students. This year it was organized during July 11th to 22nd jointly by the Robert Bosch Center for Data Science and AI of IIT Madras and PSG College of Technology in the area of data science, AI and ML. It received a very good feedback from the attendees. ACM India has instituted 3 prestigious awards: Early Career Researcher Award presented to individuals in their early career who have made outstanding contributions to computing while primarily working in India. The second one is Outstanding Contributions to Computing Education Award. The third award is for Outstanding Contributions in Computing by a Woman. Now I will say a few sentences about ITICSE. It is the Indian counterpart of the ACM chapter on Special Interest Group in Computer Science and Education. The aim of this SIG chapter is to increase the research in computing education, as well as to discuss the CS curriculum, pedagogy, assessment, and tool usage in all these spheres. I would like to take this opportunity to encourage the faculty and students who are attending this webinar to consider becoming ACM professional and student members if they are not already, for a very nominal fee. Faculty who would like to contribute to the cause of improving the quality of computing higher education, kindly consider becoming members of ITICSE chapter. The membership is completely free. This webinar by Dr. Barbara Ericson will be moderated by Dr. Viraj Kumar, who is a faculty member at IISc and also an ACM India Council member. Over to Viraj.
Thank you very much, Chitra, and good evening to everyone. So I want to just share a few words about our speaker. We're delighted to have Dr. Barbara Ericson with us. So she's an assistant professor of 2 schools at the University of Michigan, the School of Information and School of Engineering. So she, along with Mark Gusdale, received the very prestigious Carl V. Karlstrom Award, Outstanding Educator Award in 2010 for their approach to computing education, this approach called media computation, which I believe Barbara will be speaking about today. She's also the author of several books on this approach. Barbara received her PhD in 2018 from Georgia Institute of Technology, and her work in Parsons problems is also something that she will be talking about. So she has a lot of interests in computing education research, learning analytics, and these other areas that are listed here. But I wanted to mention specifically her work in Parsons problems is how I got introduced to her work. And she's doing some really, really amazing work, which has implications for all of us across the world. She's part of a very large multinational study, and hopefully we'll have a chance to learn how to participate in that. So she'll be presenting some of her work in this space on active learning in general. Barbara, we're really looking forward to your talk. Over to you. I'm going to stop sharing my screen and you can get yours. Yeah, thank you. And I'll be keeping track of the chat. If you have questions for anyone, for Barbara, I'll keep an eye on the chat.
Thank you, Chitra and Viraj. I appreciate that. Welcome, everybody. I'm excited to share with you some of the stuff I've been working on. Some of the things that I'm trying to solve is many courses are very large in computing, or there's a lot of people that are interested in computing and we can't reach all of them. So many of these courses use lecture or passive learning, where students just sit there. It's sort of the transmission model of education, where somebody talks and you just listen and therefore you've learned something. But these courses often have large failure rates, and then students who have less prior experience are more at risk of failing. And so what I'm trying to do is increase the use of active learning. And active learning has been shown to improve student learning, motivation, and retention. And it's based on theories from three people: Piaget with constructivism, where students learn by constructing knowledge, adding knowledge to what they already have. So that means the student has to be active while they're learning. They have to be constructing the knowledge. Vygotsky was a proponent of social learning, that students learn best when they're interacting with others. Often we expect people to work by themselves, which is not optimal for learning. And then Seymour Papert, who invented logo and constructionism, where learning is most effective when you're working with others, but also and doing something you find interesting, so creating some meaningful product. So what I've been doing for a while now is I used to do a lot of work with secondary teachers, and I found that secondary teachers couldn't buy books but once every 7 years in Georgia, the state in the United States where I was working. So we started creating free and interactive eBooks because we really wanted to make change. We felt we had to make the books free. And I've also been exploring, as Viraj said, mixed up code or Parsons problems, where you are given all the correct code to solve a problem and you have to drag it. So here's mixed up code to drag into the right order on the right-hand side. And then I'm also adding support for peer instruction, which is one of the things that we have the most evidence for improving student learning and motivation. So those are the three things I'm going to cover today. So first of all, the interactive eBooks, we've been working on something called Runestone Academy, or just Runestone. And this is Brad Miller, who founded Runestone Academy. He was working on creating a new edition of a textbook, a written book, and back in 2010, and he said, you know, I just don't want to write a textbook anymore. At this point, we should be able to have books online that are interactive. So he created Runestone, and his goal was that everybody should be able to learn computing, even if they can't afford a $100 textbook. So he wanted books to be free. So he started with one book, How to Think Like a Computer Scientist, and made it in Python and interactive. He added the ability to run the code directly in the book. That was back in 2011. Now there's over 30 books on the Runestone platform for both computing and math. And we have an average of 2 million page views a week on Runestone, which makes it about in the top 1% of websites in the world. And we had a paper, if you want to read more about that, at ITICSE in 2020. So if you want to see what all the books are available, and there's many books available, you can go to this URL. And there's over 30, as I said, and there's algebra and data structures and a whole bunch of different things. So take a look there. These are the books that I've been working on. So Python for Everybody, if you're familiar with Dr. Charles Severance, who also is at the School of Information with me at the University of Michigan, has a very popular online course, Python for Everybody. And he had a static book, and I've been making it interactive, and I've been adding new content to it because I teach an intermediate class, so I've been adding intermediate content to it. CS Awesome is the book that actually is the largest audience. This was created for advanced placement computer science, which are courses that secondary students can take for credit and or placement in the United States. And this is an object-oriented programming in Java course. And there's an equivalent enough colleges also teach this material that we created another version, CS Java, for people that don't want references to the advanced placement exam. I've also, at Michigan, they teach C++. So I was trying to get them an interactive book by taking the How to Think Like a Computer Scientist C++ edition and making it interactive. And these codes after it are the codes you would use to add that book on Runestone if you want to have access to that book. Student CSP is actually the first book we started with. There's a new advanced placement course beside the object-oriented programming in Java book. There's a new course, CS Principles, and this was to help teachers especially and students get prepared for the programming piece of that. It's a very small part of that course. They just do variables, strings, loops, conditionals, functions, that's it. So that's how far that one goes. And we have a lot of our media computation approaches in that book. And then one of the newest books we're working with is a discrete math book from Oscar Levine, and we're trying to make that more interactive. So what do I mean by an interactive book? Well, my PhD was in human-centered computing, which is computer science plus psychology, sociology. And what I'm trying to do is add what we know about how people learn from educational psychology and apply that to the learning of computer science. So one of the things we know is that worked examples or an expert's worked out kind of a problem plus practice is better than just giving people practice. So in the eBooks, we used a worked example plus practice approach. And then we give assessments with immediate feedback. If you've ever tried to learn without feedback, you'll know that it's not the best learning environment. So I used to sing in a choir, and yeah, I'd sing and I'd practice, but I'd get no feedback about how I was doing. And so I didn't improve a whole lot. Whereas if you're working with a tutor, you get a lot of feedback. So it's important for students to get feedback about whether they're right or wrong. Let me show you real quick one of the books in action. Let me stop sharing here and share this. So this is the Python for Everybody interactive version. And as I talked about Seymour Papert, who was working with Turtle graphics. So this is an example with Turtle graphics. Here is a worked example where we have code that the students can just run. They can modify to see what happens. This is all Python that's changing to JavaScript and running locally on the computer. So it's very fast. Oops. GHT, if I can spell, there we go. So worked example with comments to explain what's happening, followed by practice. So asking you like, which way does a turtle object go when it's first created, and you get feedback right away. So if you said north, that's wrong, but it went that way first, which would be east. So you get immediate feedback. And then we have practice. So here's a Parsons problem or mixed up code problem where I've given you all the correct code to now draw this picture, but there's also pairs of correct and incorrect code. So here's 6a from turtle lowercase import and 6b from turtle uppercase import. So you might have to go back to that example to look at, oh, what is import? Oh, import's lowercase, but hey, look, screen and turtle are uppercase. Wonder why that is. So the idea is to get the student to start paying attention to things that are important in the language, like that case matters. And then they just drag the blocks from the left side to the right side to assemble a correct solution. So now if I normally went east and I want to go south, I'd have to turn right, and it's right, not turn. And then there's a long side and a short side. So there's 150 and a 75. So I'll go the long side. If I was facing south, I'd want to turn left. And part of why Seymour Papert was using turtle graphics is he said that let you use your body to understand things. And so here I'm going to use turn instead of forward, and then it'll highlight what block I have wrong. And so I can instead switch and go forward. Now it's correct. So that's what a Parsons problem is. Let me stop sharing a moment and come back to that. So the ebooks have a lot of the standard things. They have standard instructional materials you might have just seen, right? Text, images. You can also have videos interactive. And then there's a whole bunch of different kind of practice questions. So there's multiple choice questions where you can pick just one single answer or multiple answers, as this shows. There's fill in the blank questions where they have to answer by typing something in, and then we use regular expression to check that answer. There's matching where I can have definitions over here or definitions here and terms here, and I can drag them together. It's a very simple. This is kind of an interesting feature that a lot of places don't have. It's clickable code. So click on all the function names in the code below to get them to sort of know what a function name is versus a header versus a body. And if you click on things and then say, check me, it'll highlight the correct and the incorrect. So you can fix, if you thought that was also a function name, that's a function call. And then if you're familiar with Python Tutor, this is Philip Grove's work where you can walk through and just step through code and see what the values of variables are, which is a lot easier than using a debugger. So this is integrated into the ebook for Python and Java and C++, all of those, I believe. And then write code problems. So you are able to write code in the ebooks directly. It's executable and editable. So Python gets translated to JavaScript, run locally. C++, Java are run on the backend server. SQL, I'm not 100% sure if that's backend or not, but all of these can have unit tests, so you can see whether or not they wrote the code correctly. So this is even SQL, you can have unit tests. And then we also can have audio tours of code to explain code. So this will highlight one or more lines of code as it describes the code.
Create a variable called height and set it to 60 inches. Create a variable called weight and set it to 110 pounds. Create a variable called height squared and set it to the square of height, which is.
So as you can see, it'll highlight one or more lines of code as it explains the code. We've had teachers tell us that this is
height and
useful for them to learn how to talk about code, to model how to talk about code. One of the features I use a lot is timed exams. So I do all my midterms in Runestone. So you can set a time limit. So I set time to 80. I also create different versions because I have people that have double time or time and a half. And then I put in their typically my exams will have multiple choice, fill in the blank, Parsons, write code with unit tests. But these, they don't get any feedback. They can drag the blocks, but they don't have a check me button. Write code, they can run the code, they can compile it. They don't see the results of the hidden unit tests. And then it's auto-graded. You can also manually grade, like the fill in the blank one. Sometimes I'll review myself to make sure that there's not some things that they did that I didn't give credit for, but you can both fully auto-grade or you can override the auto-grade if you want to for things. And you can have a list of problems for each question. So if you want to say, I want to generate sort of different exams for people, then you could have a list of equivalent problems and it will randomly pick one of those per exam. There's also a space practice tool. We know that people think that they're better at learning when they mass practice, they study right before an exam, but for long-term learning, spacing your practice over time is better. So Iman is a student at the School of Information, and he developed this tool, which is part of Runestone, where you can, as an instructor, I can give X number of points for solving Y number of problems a day over Z number of days in a semester. And there's an algorithm that predicts when you're about to forget a topic to bring that topic back. And every hour of practice was associated with 1% increase in the final grade. And that was a paper we presented in 2019 at ITICSE. There's a lot of features for instructors for Runestone. So as an instructor, if you want to use any of these free books, you can do that. You can create a custom course. And all that really means is that that creates a version of that course for your students to register for. So you can create assignments, you can grade them. And then, so once you do that, it's like here, I've just created mine for fall. So fall 22 SI 206 is the course I teach. And then I would have students register for that course using that course name. And then I can create assignments. So this is the instructor page that lets you do all these sort of things, manage students, add TAs, reset exams, copy assignments from another course. And I can create assignments either from existing readings and problems, or I can even author new problems. And there's an instructor guide if you want to learn more here. So the research on ebooks, I really think ebooks are the future. I don't see any reason we should have just plain textbooks anymore for learning. They have better learning gains than static books. They increase student performance and satisfaction. All of my students always say that they like having an interactive ebook. Reading time in the ebook. So there has been lots of efforts to try to figure out how to identify struggling students. And one of the things people have done in the past is just reading time in a book because they didn't have any interaction. But interaction time is a better predictor. And you can use the ebook data is very fine-grained data. So hopefully we can use that to identify struggling students and also hopefully create personalized learning for them to help them learn. And then I did a study with teachers that found more of the teachers who used more of the interactive features and spent more time in the ebook, that increased their confidence in their ability to teach the material. Because remember, one of the things we were trying to do is get more teachers to teach this. I've been creating a series of 4 courses based on my course, and these are all free. They're on FutureLearn. So if you're interested in those, these are the URLs for these, and I've made them to encourage creativity. So expressing yourself in Python, where you create a story, where you do adventure game sort of things. Power of object-oriented programming. There's debugging, hunting, and squashing bugs. I'm working on the 4th one, which is going to be things like SQL and Beautiful Soup. So we started showing you Parsons problem earlier. What is a Parsons problem? Well, there's some sort of there's some sort of problem description. What is it you're trying to solve? It has code fragments with 1 or more lines in the fragment that have to be placed in order. Some of them require indentation as well. They can have distractor blocks or wrong blocks not needing a correct solution. And they should have less cognitive load than writing the equivalent code because they reduce the search space, right? You don't have to think about all the things you have to do, just these blocks. So in my research, I found that I put a bunch of Parsons problems in an ebook originally, and then I looked at the log file analysis, and I found that a lot of people attempted them compared to nearby multiple choice questions. So that was good. People were interested in solving them. But that some people really struggled and never solved them. And we know that practice isn't successful if people don't ever practice isn't good if you never get to success. So I wanted to help people get to success. So I made them adaptive. And so if you're struggling to solve the current problem and you've made at least 3 incorrect solutions, because I want you not to just get the right answer right away, but you've tried at least 3 attempts to solve something, then you can ask for help. And so here I am dragging the blocks over to try to solve this. And once I have them all there, I'm going to check it, and I see lots of errors, and I make at least 3 incorrect solutions, and I have to change the solution. Then it tells me, hey, help's available. If I ask for help, it's going to remove an incorrect code block. Notice it pairs with the correct, which was a hint, hey, use that one. And then I used to provide indentation, but I've stopped doing that because I found that people found that confusing. And then we start combining blocks. So that's what I mean by this. And that we found with a log file analysis that helps people get to the correct solution. Then there's also between problems, so that was within a problem. As you're struggling, we can dynamically make it easier. But we also look at your performance when you have one problem to the next and say, okay, if you had a hard time the last one, we want to make the next one easier for you because we don't want to keep you frustrated. We want you to be challenged but not frustrated. But if the last one was easy for you, then we'll try to make the next one harder. So we won't, if you're making it easier, we won't don't show distractors as pair, or making it harder is don't show distractors as pair, just randomly mix them in and use all distractors. Whereas by making it easier, remove some of the distractors, pair the rest with the correct code to make it a little easier for you. So some of my findings, so we did a randomized controlled study, and we compared solving Parsons problems versus fixing code, the same kind of distractor errors as the Parsons, or writing the equivalent code. And we found that people were significantly faster at solving Parsons problem than writing code or fixing code, with similar learning gains from pre to post. We found students were nearly twice as likely to solve adaptive than non-adaptive. An observational study with teachers said that they felt that solving Parsons problems helped them learn to fix and write code. Interesting story there. One of the teachers, we had blocks of code, and one of the things in Python is easy to miss is that colon that you need at the end of a for loop. And one of the teachers looked at the 2 blocks and said, how come you have 2 of the exact same block? And I went, no, one's missing a colon. And he kept using the one without the colon for the first few Parsons problems. Then he got to a fixed code problem and he went, colon. So that was part of what I wanted Parsons problems to do, is train you to see those kinds of things, because we know people struggle with compiler error messages. They don't know what they mean. So teachers felt that solving Parsons problems did help them learn to fix and write code. And most students, I've been doing student evaluations, find Parsons useful for learning to program. However, there are people who would prefer to write code from scratch, and particularly if they have more prior experience. This is my student, Catherine Cunningham, who's graduated now. And one of the things she also did was when you're creating materials for people that don't want to be software engineers, often they don't want to know the nitty-gritty of programming, but they do want to be able to create interesting things right away. So how can we solve their needs? So she calls these conversational programmers, people who don't want to be programmers for a living, but want to learn how to talk to other programmers. So that she found is she tried to create purpose-first programming, where the first thing they would do is order the sub goals or plan goals as a Parsons problem, then order the plan code with slots or openings for things that they could change, and then have them give them code where they could fill in the slots. And she found that she was able to teach them the beginnings of Beautiful Soup in just a very short amount of time, and they really enjoyed it. Carl Haynes is just finishing as well, Megar, and he has a postdoc at CMU. So he was investigating the cognitive load and efficiency of Parsons problems versus write code within subject studies, because cognitive load is very specific to a person. So what we found in general is they're usually a lower mean cognitive load for Parsons, not always significant. Lower medium time to solve for Parsons, not always significant. And one of the interesting things we found is if the Parsons problem solution that we gave you, and right now the tool requires there to be one solution, if it's doesn't match the most common student written solution, then it actually can take people more time because it doesn't match how they would solve it. We also saw an ordering effect, though, so that if students solved an unusual solution Parsons first, and then we asked them to write the equivalent code, they tended to use the unusual solution in their code, which shows that they can learn new patterns or new ways of solving things. He found some people really hate Parsons problems, and then he's run a study with neurodiverse students who liked the adaptive Parsons problems to help them learn. So one of the things we've added, since Parsons problems really are intended to be scaffolding to help people that are struggling, is that scaffolding should fade as you develop expertise. So if you don't want to solve the Parsons problem, you'd rather write the equivalent code, we should let you do that. So we've added this toggle feature, so that if I'm giving you a Parsons problem, you can switch to the equivalent write code problem with unit tests, so that you could do that. And then we grade whichever one you leave in the page. Another one of my students is working on horizontal Parsons problems for regex and for SQL. So this is where you have just a linear line of symbols that you're creating. And this is Zihan Wu, and she has run a within subjects think aloud study. Students found the horizontal Parsons easier than text entry for regex, and Parsons problems, though, are more limiting, right? Isn't necessarily the way that you would solve it. She did a between subject study as an optional assignment for a MOOC. And what we found is that people that had to type the regex dropped out at a much higher rate. The Parsons kept more people engaged, and more people stayed through the end of the study. And the Parsons condition had higher learning gains on the meaning of symbols and took less time to complete. And she's going to continue that work. What I'm really excited about is if we can generate the most common student solution, and we're using overcode for that, we could then generate Parsons problems, and we could help you if you're struggling while you're writing code. So of course, in computing, we want people to learn how to write code eventually, but they can really struggle. So when you're writing code, if you're stuck, what we're allowing is using that toggle feature to pop up a Parsons problem. You could solve the Parsons problem, but you can't just copy the solution here. You'd have to at least retype it. You can't just copy paste from here. We found so far that, and this is my student, Jingying Hu, and working with Zhu Wang, and she's done a think aloud study, and the students use the Parsons problem both as a way to sort of look for information that they'd forgotten, like syntax for things. They're like, oh, it has to be here in the Parsons problem. They liked that it made them think, that gave them the right direction to go. They didn't always solve the Parsons problem. And then they also used it to debug, so that if they had finished writing code and it wasn't working, they would solve the Parsons problem to see what the difference were between theirs. We also tried a learning study, but we had a ceiling effect, so it didn't quite go as much as we'd like. So we're going to try that again between subject study. But the group in the hint condition did have a better learning gains on write code problems, but it still wasn't significant. So we're going to try that again. I am leading an ITICSE working group on Parsons problems. So there's we've done an extensive literature review, and then we've been creating studies in a box, and there's linked to these studies. And as Viraj said, you can get involved in these studies if you're interested. We'll make an announcement once everything's ready for fall. So we're creating materials so that lots of people can participate in the study. Right now we're doing Python. I'd also like to do Java. We'll see if I have time to create those. And right now we've created two things for Python 3 plus list and dictionary. So once you've covered those things, You could run this study, and this is Parsons versus Write Code. Whereas this one is another one that's very similar, except it's Write Code versus Write Code with Parsons as scaffolding or hint. And this one is right before you've introduced classes to see what is the learning gain from solving Parsons with distractors versus without distractors. So another thing I want to talk to you about is peer instruction. Eric Mazur from Harvard was teaching for years and was getting good student evaluations. His students were doing well on tests. But he gave them this assessment of just basic physics knowledge, applying basic physics knowledge, and found that they couldn't solve those problems. So they couldn't apply what they knew in real world situations. And so what he did is invent something called capital P, capital I, peer instruction, where he displays a hard multiple choice question. Students answer often with these like clicker devices. Then they discuss with their peers, as you can see here, people talking to each other, and then they answer again. So this is part of social learning. And you also can have the students read material before lecture, it's sort of optional, and then do an assessment at the beginning of lecture as points to get them to do the reading as optional. And then during lecture or during any place where you're basically talking at the students for a long time, instructors then display a hard multiple choice question every 15, 20 minutes or 10, 15 minutes. Students then answer individually, discuss answers with peers, answer individually again. And then the instructor shows the results of both answers and leads a discussion. They have over 10 years of results from peer instruction. So the research on peer instruction shows that twice the learning gains over traditional lecture in physics, increased student understanding and engagement in many fields, including computer science. And in computer science, both in introductory and advanced, it's reduced failure rates, improved retention, increased final exam performance. And this is a good paper to read if you have not yet about that. So what we've done is, rather than have these clickers, which I used originally when I started teaching, and what I wanted to do instead is just put everything in the ebook. I mean, we have multiple choice questions in the ebook. Why do I need a separate device? So we've added that support in Runestone so that you can ask a peer instruction question. We've also wanted, with the pandemic, the ability to pair students even if we weren't in person. So we added this chat window where you answered B, your peer answered C, please discuss your answer. So you have a little chat window where you can do that. And you could also rate how good is your peer's answer. This is confidential.
Barb, sorry, there's a request if you can go a little slower because the stuff is really interesting, but some of us having difficulty following it. If that's possible, sure. Yeah, thanks.
Right. Thank you. Yep, I get speedy sometimes. All right, so yeah, that's peer instruction. And then this is the instructor's interface. And part of what we've learning is that when instructors say they're doing peer instruction, they often don't follow the recommended procedure. And the recommended procedure is you let everybody vote individually first. So when they go to the tool in Runestone, they would see this interface and it starts the first vote right away. And then they would see the number of answers go up right here for a while until it sort of slows down, is usually what I say. And then I usually will tell people, okay, you have 5 seconds left. I'm going to stop the vote. So I'd click the stop vote 1. They get a 5-second countdown. Then we enable the discussion, which will bring up the chat interface that I just showed so that you can discuss it. And again, we have over here, we'll have a number of messages sent. So we kind of get a sense for how are people discussing this? When do they slow down? Then we'll start vote 2. So the second vote, and again, they have time to talk. You'll see the number of votes here, and then we'll stop that vote. And then you'll typically show the graph. So you get a histogram of how many people answered A, B, C, D, E first vote, and then second vote. And usually what you'll see is the percent of people who get it correct goes up from the first vote to the second vote. And we'll see. So that's the process, which is a nice little short way of doing it. The important thing for peer instruction is it's got to be a hard question. Because if it's an easy question, everybody gets it right, then there's no reason for people to discuss it because they already got it right. So nobody's going to learn a whole lot from that. So you can just explain the answer and move on. If nobody gets it right, then it's hard for anybody to convince other people that they had the right answer. So again, you could just go back and revisit the concept or try to figure out what they're not getting. So you really want about 30 to 70% of the people to get it correct. Closer to 50 is better, right? So that they learn from the peer discussion. So what we're doing right now, we've created the tool and I used it in the fall, and we're getting ready to do a study in 2 different courses I used it in the winter. We're getting ready to use it in 2 different courses in the fall. And we've been adding questions. One of the other issues is there are a whole bunch of already validated peer instruction questions for CS. There's this website here, peerinstructionforcs.com. But what's difficult about that is what they did is share their slides with the peer instruction questions embedded in the slides. So you have to, if you want a peer instruction question, you have to go look there, download the slides, try to find a peer instruction question that sort of matches your content. So that's difficult. So what we've done instead is put them all in the eBooks, and we use the author's name. So like if you want to look at Dan Zangaro's questions for CS1 and Python, you could search for all the questions that start with DZ-. If you want to look at Cynthia Taylor's, you could do CTP-. There's also Peerwise Question Bank that we've gotten questions from, and the Canterbury Question Bank. And we're adding questions right now from Java and C++ this summer so that you as an instructor don't have to constantly create questions. So in summary, the idea is that active learning can improve student learning and engagement through interactive ebooks, Parsons problems, peer instruction. And then ebooks also, one of the nice things as an instructor is they can reduce the instructor's workload because there's lots of practice problems you can assign. Students actually can code right in the book, so they don't have to download and install anything to work. There's automatic grading. So Runestone, of course, is our system that I've been working on. But if you're not familiar with OpenDSA, you should also check that out. That's another free system that was more created for algorithmic animations originally, interactive algorithmic animations, but it's also another free one. You might also have heard of ZyBooks, which is a commercial platform. So that's my presentation.
Okay, Barbara, thank you so much. So I've requested questions on the chat, and while we're waiting for those, I thought I'd start off with a few of my own. Yeah. So, if I'm an instructor using some of these ebooks, what sort of analytics do I get on a per student basis?
So there are some overall student analytics. You can see where, what have students done? I can't show.
Sure. Of course.
I can't show.
Of course. Yeah.
But you can see, okay, I assigned chapter 1. How many people have read that? Have they done the assignments? What problems are they struggling with? So you can look at all of that.
So, for instance, you showed some of those multiple choice questions where I think they could attempt it any number of times, right? So, could you see if I have attempted it multiple times and I've got it wrong the first time and so on?
Yes.
Okay.
Yeah, and you can see a donut chart. Like what % of people answered correct the first time, eventually got it correct, never got it correct.
Mm-hmm. Okay. So there's an interesting question from Nishta on the Q&A is how do you handle batch sizes of 50 to 60 students without TA support? So I remember we were discussing yesterday that many of our institutions break large batches into these smaller sections. But I think what Nishta's question is pointing to is many of us as instructors are responsible for the single group of 50 to 60, but we don't have TA support. So maybe another way to phrase her question is how critical is TA support for running some of these courses through ebooks?
Right. So I think that's one of the things that ebooks help with, right, is the students have feedback. They don't have to wait for office hours to go get help. So especially the write code problem with Parsons as a hint, because one of the things that our students struggle with is how to write code, and then they have to wait hours for office hours and go see a TA. But if you give them the Parsons as a hint, they don't have to do all that. So I think we can help the students a lot more. And then also for practice, rather than giving them write code problems all the time for practice, like I'm in a large lecture hall with 150 people. So when I give them practice, I don't give them write code by itself as practice. I can't reach 150 people, but I can give them Parsons problems. And because they can get to the correct solution, I don't have to walk around and help them all. I can't ask them who's having trouble with stuff and I can go over it, but they can all get to a correct solution without me having to do that.
So there's a question from Ram Rustagi about, with C and Java, where you have all these curly braces around there. How does that work for Parsons problems?
Yeah, we have them in Java. Hang on one second. So for Java, one of the things we had to do, I'm just going to change to a different course, change course over here before I start to share my screen. So I can show you them. Right, the curly braces, we don't really care which curly brace you use, right? So what we've done is we match the contents of the block, not the block itself. So as long as the curly brace matches, that's fine. Let me go ahead and share that one, so you can see what these look like here in Java. So here's the CS Awesome book, which is, I didn't name it that, but it was a great name because every time we show it to people, they're like, that's awesome. So I love that it sort of gets people to say that. Let's go to something that's a little more interesting. Go to strings, Boolean conditions. I'm just trying to get, you can see this is a long book.
Sure.
One I've been working on for years. So it's quite extensive. It is College Board endorsed curriculum. So it does match up with what the College Board wants for this course. Where do I want to, which one do I want to do? I guess I'll do here. Oops, and strings. There it is, mixed up code practice. Oh, that's the MakePylab. No, I don't do that. They've changed the book a little bit on me, so it's a little bit harder for me to find.
Sure. In the meantime, yeah, go ahead.
Mixed up code practice. So make that bigger. So as you can see, we've got curly braces, public static void main. Now this is, you can decide whether or not you want them to provide the indentation or you want the code to already have the indentation. In this case, this is early enough that we're giving them the indentation, which of course is a hint. And then sometimes I'll put these comments early on too, to help them see, hey, this is this.
Yeah, I think this was Ram's question, that I think you do have some sort of separate blocks for these the trailing, the closing curlies, right?
Right, but
you have
but
to
it
have
doesn't. Yeah, it doesn't have to be that one here because I have the comments, it's in the right thing, but eventually they're just the curly braces. And so what it does is just match the contents. So it's okay if it's whatever one it is, as long as it's the right contents.
Got it. So as long as they're matched, yeah. Okay, so there's a couple of questions in the Q&A about how to sort of operationalize this. So one question is, how much time do you recommend devoting to active learning, either daily or weekly? And then Venkatesh is asking, how does one actually use these ebooks? Is it in the classroom or at home or both?
Both. I use the ebook for everything, right? So I assign readings out of it for them to do before lecture. I actually also, I didn't talk about, but I try not to lecture a whole lot because we know that it's not very effective. So what I prefer to do, let me go to the right book now, change book course. So you can have many books, you just change course to get to the right one. And of course I have tons of them.
Yeah, actually this was one of Chitra's questions asked about, are there also books on data structures?
Yes, there are.
And algorithms, yeah.
Yep. There are plenty. Yeah, take a look at that library list.
So yeah, actually there was an earlier question, Barbara. You flashed a lot of links. I tried screen grabbing a little bit just so that we could have them, but later on, if we can have either the slides or at least the references, especially to the papers and the links, that would be fabulous.
To share the entire talk. Yeah.
Oh, that would be great. Many thanks.
Course.
Yeah.
No, I don't expect everybody to remember all that. So one of the things I've been experimenting with in my course is to not lecture very much, instead to design these POGIL activities, which are process-oriented guided inquiry learning, which is a mouthful. Basically, it means group work, but guided inquiry, so that you set them up to learn the things you wanted them to learn without you just telling them. So instead of me lecturing about the basics of Python 3, which is what I used to do, I now give them these, which is some example code to learn from. So my students come in, they're supposed to already know what a variable, loop, function, condition are in some language, not necessarily Python. So I start them right off with functions. How does this work? And then I ask them to predict what's the first thing that's going to be printed. What's the second thing that's going to be printed? So they have to know that, code starts in the main, and then it would call the main, and then it would print hello, and then it'll call test3. So it gives them something to think about. How does this work? And then, oh my goodness, look at all this stuff here. Instead of me talking about the basics of these, it's going to print what all of these things do. So they can of course cheat and run the code and then just go type it up above. I can actually tell them the log if they do that. But it gives them something to think about, right? Here's a worked example to think about and run, and then questions about it. And then like, what's the value of B when the test starts executing? They can also use the code lens, which is Philip Gross, to walk through this to see what happens, which is really, I usually will do this then after I've had them do this, because often they don't notice the code lens right away. So the first thing it does is create the function test, then create the main. And it doesn't call anything until you actually call the main. And I'll ask them to predict what's going to happen next, where's it going next. So to show them this, the ability to step through code and see exactly what happens. And so they can see exactly how this works.
So I had a related question. This reminded me of when you were showing the audio tours, right? I mean, you seem to be going top down line by line, but if I want to sort of show the runtime behavior, function calls and so on, is that possible?
Oh yeah, you could do many different kinds of audio tours actually. So you could do a structure first audio tour. These are the variables. We designed it so you could have, I think, up to 4 different audio tours per code. So that you could actually, the problem is it takes a lot of effort to create those.
Yeah, no, I'd be curious to try, because as I mentioned to you at the back end of the ITICSE conference, we had an email exchange. I think that's absolutely amazing for our context, because we have a lot of linguistic diversity in our classes. And so some of us, we know we can communicate more effectively with our students in other languages, not necessarily English. So just having this facility, so it would be amazing for us, I think, and then I think it boils down to, as you said, authoring. And I mean, one idea is, potentially really enthusiastic students can sort of author this if that's a possibility. Anyway, we can discuss that later. But you're saying I don't have to necessarily follow the code structure. I don't have to go top down, right? I mean, I could follow control flow.
Yeah, you choose which lines to highlight while you're saying whatever you're saying. So
got it.
So you can do whatever you want.
So you have to be alert then. You don't select the wrong ones. As your
No, it's not a recording that way. I mean, you tell it what lines to highlight, right? So it's not recording you talking that way. I mean, you do make the recordings of each individual audio you want to play, but it's just a format for saying what line numbers to highlight while you play this audio clip.
Got it. No, I'd like to try it out. So. Yeah. So for the participants, if there are other questions, please do type them in. So just to clarify, anyone anywhere on the planet can use these books, right? I mean,
yep.
And they're free.
All freely available. They're all Creative Commons licensed. So if you want to take them, so people have translated them into other languages. You don't have to use the Runestone server if you don't want. There are instructions for how to set up your own server. I don't know about the privacy issues you guys have, but occasionally people are like, no, we can't have our students' data on the Runestone server.
Sure.
So you can set up your own server.
And Ram is asking, as an instructor, do I need to register, get permissions to run the course? I guess there's instructor login that's separate.
Yeah, so I put in the slides where you can, the link directly to how to create a course. Anybody can create a course. And then you're the instructor for that course when you've created it. Students sometimes do that thinking that they're going to get some answers, but they don't. So, let me see, stop sharing that, go back to the slides, but the link for that, exit, okay, there it is. Let's see, create a custom course was features for instructors. There it is. I'll put that in the chat window.
That would be great.
You should be able to go to this URL. Oops, let me find this again. There you are, Zoom. If you go to that URL, that should take you to the place to create a custom course.
And can you mix and match some of the content across the books that you have, or no?
You could, but you'd have to get it all. It's all on GitHub. So you have to get the source from GitHub and then do whatever you feel like, right?
Okay. All right. Okay.
There's no easy way right now for instructors to customize courses other than
But
that.
there are components that one can identify in the source, or is it?
Yeah, so right now our books are structured typically that every chapter is in its own directory.
Okay.
And there's an overall index that is what's the order of the chapters, and then for each directory there's a table of contents as well. So you have separate files usually for every subchapter. So it's pretty easy to just modify things if you want. And
then our course instance can just point to that repository, is it? I mean, and say get the contents from there or something like that.
So if you do the create a custom course, that doesn't make a copy or anything. That directly serves that book, but it does say just your students can register for that version. Now it doesn't change the versioning. It doesn't save a copy. So if anybody makes changes to the base course, is what we call it, you'll get all those changes. It doesn't separate it out as a static copy.
Okay, well, we should explore that. Okay, Chitra has go ahead. Yeah.
So I think skill of debugging, we're just starting that one, that use of skills in debugging. So that'll be an interesting one to check. I think it's easier for students. I love debugging. And one of my goals in my course is to get students to use a debugger. But it's hard for them because they have to have a mental model of what's happening and why is it jumping here and then jumping here and then jumping there, and do I step into or step over? So that's why I like the Python tutor as just a next, or you can go back, but it's a lot easier for students conceptually to just understand that I just keep hitting next. But yeah, I think the Parsons problem, that's the new thing we've added is, if you're struggling while writing code, we can pop up the Parsons problem and you can use that to say, what's wrong with my code? So we did see people do that, especially like off by one errors, that they were like, oh, I'm getting this out of bounds error, and they're stopping earlier. Oh, that's probably why. So it would be interesting. We haven't, like I said, we tried to do a learning gain study, but we had a ceiling effect from pre to post. So nothing was significant, or not much was significant. So we're trying again. We've recreated materials and we're trying again.
While we're on the subject of Parsons problems, you mentioned briefly these horizontal Parsons problems. I think you mentioned your student Zihan Wu, I think, if I got the name correct.
That's correct.
So there was actually so I've been trying, prior to this talk, I've been trying to popularize Parsons problems. I've been running a few faculty development programs, and so one of the comments that I gave this presentation on Parsons problems at a university where there were non-computer scientists, a lot of non-computer scientists in the audience. And there was someone from the languages who said, I could use these to show how complex words are broken into parts. And, I could think of a Parsons problem that says, does it decompose this way or does it decompose that way? So some of our languages, Sanskrit is one of them, which is very, very, very strong set of rules in terms of how complex words are decomposed. And they could see that. But they said, I'd need the horizontal form factor for that, because that's how we write it in the textbooks, and that's how students are comfortable with it. So what I didn't get from your quick showing of her work is, so is it in a computing context or some other context? I missed that, I'm sorry.
We are using them in computing context. So for SQL, SQL,
okay.
For assembling SQL commands, but also regex, which regular expressions, which are very terse symbol language. But we also use it like Java, public static void main paren string. That's a lot for somebody to get right. Yeah. So we think we can use them in many contexts. I mean, I use them in Duolingo all the time, right? Duolingo has has this sort of feature. So it's not a new idea. Sequencing actually has been around for a long time as something to have people do, but we haven't had the support in our tools until recently. So we do. She has added that to Runestone, so we are going to be testing that as well in the eBooks. Okay. And I think it'd be really interesting, to go from the vertical Parsons problem. If you're choosing a distractor a lot, maybe we give you then the horizontal, get you to focus on that piece.
And so all these variants, some of which you talked about, your research, adaptive Parsons problems, etc., all this is available as one of the problem types if I were to run a course. So, I mean, as you experiment, do you add them also to the...
Oh, yes.
Okay, great.
Yeah, everything we do, I try to, my goal is to get people to actually use stuff, not.
It's amazing.
I like people trying things and working. I want things to actually be useful for people. So I do randomized controlled studies, but I also test things in the wild, in actual educational use to make sure that it isn't just a lab effect, that, it is something that you actually can find useful.
So other questions? We're almost out of time. I wanted to just say, I'm convinced we're using one of your ebooks at our institution. I've convinced my colleagues that this is really, really great. So I'm hoping others will also find this extremely useful. Chitra, go ahead. You had some questions, right? I think there was a follow-up question or comment.
No, just a comment, because during the past 2 years of pandemic, so we were conducting this sort of multiple choice questions. And there, you have to really come up with those choices which are very close, but they are not correct kind of. That is, we were working very hard for setting up such kind of multiple choice questions, because coming up with such kind of distractors where they possibly will choose such kind of answers which are very close to the correct answer. Yeah, that's what I would suggest a comment. Yeah.
Yes, that is the tough part about creating good multiple choice questions. And that's why we wanted to make it easier for people to find and reuse good peer instruction questions, because they're hard to come up with.
That's true. Yeah, it's a very, very interesting technique. I loved the way in which these Parsons problems are constructed. I think definitely for beginners or even a little, that is when they are getting into the programming for the first time, it will really help them and boost their confidence that they also could program. That I saw that blank screen problem. I think I can relate to that starting problem, that where to start kind of a thing. Yeah.
Yeah, and I'm really excited about using them. So one of the things we found when we had people write code and then had a Parsons they could pop up is that some people popped it up as soon as they read the problem description. They immediately popped up the Parsons problem. So what we're thinking of is really what they wanted to do is get an idea of the algorithm for the solution. So we're thinking if they pop it up immediately before they've even typed any code, give them a sub-goal problem as a Parsons problem rather than the code, because we don't want to immediately give them the code, sort of, right? But then we found that they basically popped it up 3 different times. One is immediately after they read the problem description to get an idea of the solution. Is it using this kind of a loop or that? What's going on? And then sometimes they wouldn't until they'd started writing code. And then when they got stuck, like, what's the syntax for that thing? Then they'd pop up the Parsons problem as a form of directed search. So instead of Googling for how do I do X in Python, they said the answer's got to be here in the Parsons problem. Oh, okay. They just look at the blocks and go, oh, yeah, that's the syntax I forgot, and then go back. So they wouldn't necessarily solve it. And then they used it for debugging. So if they wrote all their own code and then got errors on the unit test, then they would pop it up and perhaps even solve it to then compare and go like, okay, so how do I debug this, right? What's wrong with my answer? So I thought that was really interesting.
Yeah, very much so. Barbara, do we have time for one more question? It's a quick one on the Q&A. Do we have any resources for SQL? Yes.
Right. So as I showed, you can do active code. And in the Python for Everybody book, I do teach them SQL. And that's one of the things I find that they had trouble with, right? So I wanted to give them more practice with assembling SQL commands. So that's why part of why we did the horizontal Parsons problems. So we're adding those as well.
Okay. Barbara, thank you so much from all of us for spending your time, and really appreciate it. Chitra, over to you. Yeah.
Thank you, Barbara, for accepting. And that is, even though you came back from Europe just a couple of days back, and you managed to deliver this webinar. Thank you so much for your time, and it's a very, very interesting webinar. I hope a lot of our faculty members will follow this approach in the introductory programming course, and also in this SQL and other related wherever programming is introduced, they will adopt this approach, I hope. Thank you very much, Barbara. Thank you.
Welcome. Thank you, Chitra. Thank you, Viraj, for having me.
If we crash your servers from India with traffic from India, then you'll know this was the cause.
The nice thing about Runestone is that it's been able to handle the load, no problem.
Great. Great. Thank you once again.
Thank you.
Bye-bye.
All right. Thank you, everybody. Bye.